we're gonna talk more about Minecraft. You may want to use Minecraft for your Game AI Jam, who knows? Anyway, we're gonna hear a lot more interesting stuff about this. So Anssi Kanervisto here will talk about AI that plays Minecraft, particularly the environment, the Malmö environment for Minecraft, which is like somehow named for the city I'm from. Absolutely no relation. I am nothing to do with this. So Anssi did his PhD in in the far east of Sweden. They call it Finland. It's
Östra Finlands universitet.
Right, Östra Finlands universitet. Tack så mycket. It's an independent country now, I hear, and that's great. It's 200 years more or less. So, and in his PhD there, he's participated in and done very, very well in several of the sort of game AI competitions, including the Wisdom competition, the Obstacle Tower competition, and the Minecraft, the Malmö competition. And he's now running these. And also being a researcher at Microsoft, he was involved in several of these papers you saw already. So I'm very excited to see what's going on here with Minecraft, and take it away.
Tack så mycket. So, oh, are we done? Okay. No. Okay, so starting off, AI that plays Minecraft, quite simple. Let's get to it. I just start off with a couple of disclaimers, which I just added in last 1 hour. This talk is only about the AI that plays Minecraft, but this is not the only thing you can use Minecraft for. So there was, for example, this generative design Minecraft competition. Yay! Where you, instead of playing the game, you try to come up with like nice settlements, generate settlements that fit into the terrain and stuff like this. So there's other things you can do with Minecraft, not just play agents on it. So just a disclaimer, but this is just about the agents. And then this talk is more about games for AI research. So we are using the Minecraft as more of as a benchmark instead of trying to create like the greatest agent in Minecraft using the AI. So just keeping that in mind. So with that over the way, who has here played Minecraft? Okay, good. Now we have a majority. It depends on who I talk to. Some never have even heard of Minecraft, which is kind of depressing. But at least now everyone knows Minecraft more or less. But generally speaking, you spawn in a random game. Oh, wow, it's bit 10. But you get the point. So you start in a random world, you go around. If you're playing the normal Minecraft and you just want to get wood logs, start to go for diamonds, start building a house, you start by getting some logs, some wood. Then you can craft the items at some point once you have enough. And I don't know, explore around, build your houses. Here we go with some crafting and so on. So you can do whatever you want. Later on, this is just the beginning of the game. Later on, you might be building a house on the materials you have. I mean, again, this is one thing you can do in Minecraft. You could be just mining around, finding ores, finding diamonds. I feel like I'm repeating this. I beat the redundant that everyone now more or less knows Minecraft, hopefully. But this is general gist of the game. Any questions about Minecraft? No? Okay, that's refreshing. So, but why Minecraft for AI? Again, I remind this is more like Minecraft as a benchmark for AI instead of creating an AI for Minecraft specifically. So why do we care about AI? Sorry, Minecraft. Why do we care about my AI? So we had already Atari, a arcade learning environment with all the Atari games. You have heard about that already. We have Doom in the form of Doom, playing games around, and you have the DeepMind spawning version of the Quake environment nobody wants to use anyways. You have StarCraft 2, which was pretty cool, superhuman AIs and all that. And you have just robotics. So why would we care about Minecraft when we have all of these? Like what is the thing Minecraft brings to the table? And I want to also note that even though I like to think I'm not that old. When I joined the game, the Atari was the kind of the end game environment, or Doom was the end game environment. That was the most complex environment. But only in like 6-7 years, that has become like a baseline, like, and it's not that interesting. So it's just kind of fascinating to hear in this talk that we had the tabletop games, we have the board games, then Atari game, and now we have already gone somewhat over that. But back to the topic. Why Minecraft? Any suggestions? Any thoughts? Any suggestions? Just raise your hand. Oh, there's so many hands, but let's start with. Compared to robotics, yes, good point. They're behind there. Boundless? You mean like there is like no limits to what to do? The world just keeps generating. That's good. There was a hand there somewhere there. There. Sparse reward environment. Yeah, it can be sparse. It can be also dense, but it's very sparse because, if, for example, you get the logs, cutting these trees takes a little bit of time. Another suggestion, just a couple of rows behind. Yes. Yeah, that's a very good one. Any more? Yeah, 3D game with the full like perspective, like first-person perspective. There.
You can it can discretize really easily.
As in terms of like the world is made of blocks, so you can. Yeah, that's actually a good one. You can just make it like a voxel thing. It's easy. You don't have to take like a 3D mesh and discretize it. There, like there. Yeah, you can manipulate the world. You can generate your own maps. You can modify the game somewhat easily. No, yes. Well, going back to the good policy, actually, you brought it up. So Minecraft is open-ended, that came up already, and has a procedural generation. So the good thing for AI research is that you get a wide range of tasks. There is no single optimal solution. Like you can solve the same thing, but in a like very slow way or in a good way. Multiple ways to approach the same problem, and just benchmark for generalization when you have the procedural generation. So instead of trying to just hard code for that one level of Atari, you now have to solve like all the environments. There was also the Minecraft a full-fledged game. What comes with that is, well, in order that was proposed, it's a 3D world with pixel-based control. Some people don't like the pixel-based control necessarily, but that's what we like here. Runs on computers. It's not robotics, so it's relatively cheap to run compared to robotics. And my favorite is that this has human players. So we get human data, we can ask humans for feedback, we can do human interaction maybe in the future at some point, and so on. So that's pretty cool, because how many millions of players Minecraft has, I don't even know anymore. And the final one is Minecraft is Minecraft, which brings Minecraft, which is obvious, don't have to even mention that. Small caveat, it's slower than Atari and Vids2, but we will make do. So imagine with the things we can do if we just take this Minecraft environment, start making AS for it. So for example, a generalist agent that solves any task you throw at it. So we had already discussions of one agent solving all the games. So you could just implement a bunch of tasks in Minecraft and train the agent to all of them and see if it can solve the unseen ones. Agent that follows instructions based on text. I made this slide maybe 6 months ago, and we have already seen papers out there, which I will touch on later in the talk, that do this. But essentially, given a large language model, large language model and instructions in Minecraft and task description, see what happens. Like, does it solve it? And then this one is my personal favorite nowadays, is see if the agent align with humans. Anybody here know or familiar with the term alignment? Yeah? Yeah, so does it do what especially humans have in mind, or what we want it to do? Does it, like, if we wanted to build a house, will it destroy the house next to it to build a new house? That's not really aligned, but it might do it because it still solves the task. So we could just gather people familiar with Minecraft, show them videos of agents solving tasks, and then ask them to see if they actually solve it or were aligned. Any questions at this point or thoughts at this point? I'm very open. I have plenty of slides, probably have to rush through some of them, but that's fine. Any comments, thoughts? Yeah? In the Minecraft, that's the tricky one. So it's open-ended. You're placed in a world which is procedurally generated. You have trees you can like cut, you have dirt you can mine through, all the stuff. And it's really up to you what to do. Now in the current versions of the game, you have some bosses to kill. And there is like advancement tree that tells that you should kill this boss and get these items and so on. So that could be your goal. But essentially, you don't have a goal. You can do it if you want. You don't have to. Does that answer your question? There is achievements now in the game. Now in the actual game, there's achievements for that to guide the player. But in this AI world, not necessarily. It depends on us researchers what we want to do. Like, so. Other thoughts? Yeah, okay. So let's get started with Malmo. in 2016 already. This was actually a cool time to start a PhD because this came out from this specific lab where I'm currently working at, so small world. So Malmö, apart from being a city in Sweden, is providing the kind of the glue between the agents or the AIs and the Minecraft game. So Malmö sits between being a plugin for Minecraft, and it takes in the player actions or the AI actions and environment settings and whatnots, and returns the observations, so images, like voxel observations or whatever you want. It's quite versatile in that sense. And Malmö uses these XML files to define missions. So you can do very specific, and oh wow, that's a bit dim, but will do. But you can define like different kind of areas. You can define different kind of ending settings or the starting settings, or you can define what kind of rewards and penalties the agent is getting. So does it solve the task fast? What items should it obtain? So on, so on. What does it even show here? Hopefully it's at least somewhat visible. But the goal there is, the point here is that it's quite versatile on the tasks you can create. And you can use that toolkit to create, I mean, you could play the normal Minecraft, but also create like mazes and balancing acts and so on. So it's not just focused on the original Minecraft game. It's more like Minecraft being a toolbox to create different tasks. Now, but how about learning to play Minecraft? Do you want to guess what I'm going to mention here? Yeah? Not the voice paper, not yet. Something more rudimentary that has come up a couple of times in Julian's talk. I think Kati will probably also talk about it. Yes? Still a bit too far ahead? Even more rudimentary? It's reinforcement learning, but god damn it, it's in the next slide. But oh well. So the task of, for example, obtaining a diamond. We want, this is now people have for some reason taken this as a kind of a grand challenge in Minecraft. Well, not grand challenge, but a challenge in Minecraft that from starting a new level with no resources, you need to obtain diamond, which is a kind of a multi-step process. So some people who know Minecraft already know how difficult it is, but to visualize it, you have to start by getting some logs shown in the video, crafting them into plank sticks, so on, creating a stone, wooden pickaxe, getting stone, finding iron, mining that, smelting that into iron ingots, and then into iron pickaxe, and so on. And then you have to find diamonds. And this is like a 13-step process of with like its own little things. So it's kind of it's quite tricky in the grand scheme of things. So how to solve this? We could use reinforcement learning. We finally got to it. And I mean, you have already seen this thing probably too many times today. You get the observation from the environment. The agent or AI selects an action, what to do, and then the environment tells if that was good or not. And then based on that, you learn from the experience. I hope I don't have to iterate this too much. I will go a bit into agent details a bit more later. Any questions at this point about the reinforcement learning thing? Yeah? Yes, so you can specify what information you want from using the config files. But reinforcement learning, sorry, there was a question?
So I'm familiar with MindFlayer, which is perhaps an alternative API to Malmö.
Right, so MindFlayer is a kind of a scripting API for writing bots in Minecraft. And that's more designed to create AIs for Minecraft, where you can specify like going to a different location or go to the nearest chest and stuff like this. Here, Malmö, I think it might have some of the utilities like that, can't remember, but it's more for research where you specify you want image pixels or observations around that, and then you use that for research. Does that clarify the distinction?
Quick follow-up question. Does Malmö have the capacity to instruct agents to perform like predefined like macros of actions? Or is it just like raw, like here's some action?
Good question. I can't say for certain that it cannot, but I haven't heard of it. Okay, so going back to the task, reinforcement learning doesn't alone cut it. So if you, in this plot, you have on the x-axis, you have number of episodes an agent has played the game to solve a task. And on y-axis, you have the reward of how well the agent is doing. And focusing, so you can see the response of different lines, but focus on the blue one, which is on the flat on the y-axis. So even after 1.4 million attempts at finding a diamond, there was not even a single reward. Like there was not even a pump. There is nothing. It doesn't learn it. And like looking at some other results where you have a couple of different algorithms used in this similar task, like getting logs instead, not the diamond, but just logs. Looking at the numbers, it doesn't do any better than random agent in that task with the DQN or ATC, which back then were the state of the arts. But essentially, the agent doesn't even do this. It's not able to like navigate around to the closest tree and log the tree. Is there a question? So those two figures were quite different. One was obtain diamond, so getting a tree or log, you would get some reward. The other table was only tree chopping, so getting logs. But in both cases, essentially the takeaway is it doesn't even do this. It doesn't even learn to do that, which is kind of sad, but oh well. Meanwhile, in other games, specifically in this example, StarCraft 2, where you have a better agent going from left to right, instead of starting here with a random agent at the very bottom of the skill, like probably the worst player ever, hopefully the worst player ever, we start around, like, I think it was better than like most of the players, like 70% of the players, with just imitation learning, just by learning from human demonstrations or traces as used by this other presentations. So with that in mind, we enter MineRL. Some people call it MineRL, but no, it's MineRL. In 2019. So MineRL is just based on the premise that an AI or agent plus Minecraft is rough time. You don't learn anything. But if you take AI, Minecraft, and expert human gameplay, then you will have cool bots. And MineRL is essentially that package. It's Minecraft and Malmö plus some human demonstrations. So the people collected like from a bunch of humans playing the Minecraft game and define a couple of different tasks. How are we doing on time? Oh, so yeah, like I said, many slides. MineRL comes with simple gym AI. I don't know how many people are familiar, but here is a simple GIF of showing this minimalistic setup of how to run Minecraft through this API in Python. So just you can make the specific task in Minecraft, reset to create the game, and then you just use step function to do, and okay, that's a bit flickery, but that's essentially executing a random action. So camera moves up and down, left and right. I will come to the action space in a second, but that's somewhat simple. And in this MineRL setup, this kind of uses Malmo to define environment, but doesn't let you modify the observation space or action space. But it defines it for you so that when people are comparing algorithms, they will all use the same observation space. So for observation, the agent will see the equipped item in the hand, usually nothing. So it's just punching the tree with empty hands, but it can't be a pickaxe. The inventory of how much coal, logs, stone, whatever it has. And then it has the POV, or the point of view from the point of view of the player, as image pixels, like a 64 by 64, very crispy, crunchy image, where it's very hard to see anything, but hopefully with a bit of distance, you can see it's going around. So we are in the pixel world. And then for the action, it's a bit more interesting in a sense. So you have your normal attack, so cutting the tree, digging the ground, attacking the mobs. You have the normal navigation, normal navigation buttons. So you choose for every one of these, you choose if it's 0 or 1. So do you press forward is on or back? Forward is on or not. You select if left is on or not, and so on and so on. Same for jump and sneaking around or sprinting, moving faster. The camera is actually a continuous where you select how much the camera moves on the both axes. And then the one difference from Minecraft is that you get these functions to quickly craft stuff. So instead of having to open a crafting table and they have the UI to craft items, which would be a lot of finicking with the mouse, you get these functions to craft items as long as you are close to a crafting station or you have the nearby or the necessary items to craft things. Any questions at this point? Because there is a lot of information here. Yep.
Was like in a pixelated thing.
Yeah.
To help it to go faster when training.
By pixelated, you mean like it's not high quality image. Yeah, essentially it's to run the game faster, to have a very low resolution image. And the AIs, at least back in the day, weren't just capable of handling like a high resolution images. There was another question. Sorry? I think it has to. I think it either has to or has to be just close. There was actually feedback regarding that, but not enough time. But yeah, this is the action space. And then finally, especially for AI research, it defined multiple tasks under one name so that people then could compare results between papers more or less. So for example, tree chop task is just to start with a forest with an iron axe to cut trees, and you get reward for logging trees. Then you have something more interesting where you have to obtain an iron pickaxe from a fresh world, and you get reward, exponentially increasing reward based on getting items. So you get +1 for getting a log, but only the first time you get a log. So you have reached that far. Then you get points for crafting it into items that go closer to pickaxes, and so on. And then finally, you have this obtain diamond task, which is the same as obtaining iron pickaxe, but you now have to use the pickaxe to get a diamond. So, and finally, the whole human demonstrations or traces provided by the dataset. So, bunch of thousands, well, yeah, few thousand demonstrations. This is not all of them, just the main ones. Not very big. It's like 10 gigabytes. I think 10 or 40 gigabytes unextracted. And you have, for each demonstration, you have 3 files. So you have the metadata just telling who is the player, anonymized player, how long the game takes, and if it was a success or not. Then you have the most interesting part, which is the video file, actually, which is also in the very crunchy, low quality image. Hard to see anything, but it will do. And then you have a file that contains all the actions for every single video frame. You have that. So for every demonstration is one complete run from start to finish, or maybe a timeout if the player took too long. And then for every step, you have the video frame in the MP4 file, and then you have also the actions the player took at that step. So you can do now imitation learning, train a model to predict humans' actions based on the image pixels, and so on. So with the MineRL setup, they also set up the first MineRL Obtain Diamond Challenge competition to kind of encourage more results in this field. Any questions regarding MineRL before we move on? There was a hand first. Not really. It was released, not really. Partially. There was another question.
How long is the step size?
Sorry, the step size? Oh, so one single step.
Like one step, like one frame?
Oh, okay. So when you do like nth step and execute an action, how long does it take? How long does it simulate the game forward? Yes. So it runs at 20 hertz. So it's 1/20th of a second per step. Right. So Obtain Diamond Challenge. This was the first. I think I personally this was as well. This is where I come into the picture of the whole MineRL scene. So the task, getting the diamond, which we also already discussed, with and somewhat interesting protocol setup. So in the round 1, the participants submitted the trained agents and the agent code. They trained themselves to the AR crowd servers where the competition was run. And it runs the agent in the Minecraft game with the specific world environment seeds, and then averages the score. And that's the final result of how well you're doing. This is very usual in the AI competitions that you submit the models and stuff. But in the round 2, instead of submitting model, they submitted only the training code. And now the evaluation server trained the model to make sure that they didn't cheat, they didn't break any of the rules. So by the organizers checking the code, training the model, and making sure that the results now are still the same, which is, by the way, much fun when you have to train submissions on your servers for people's code and trying to get the same results. And then that was the final score. So the model trained and ran on the server, that was the final score of the whole competition. So what are the rules? The big one was no hard coding. So maybe if you want to create an AI that works well, you want to do all kinds of little trickery, make the action space easier, script some parts. But we don't really want that in the research side. We want more general solutions. So many of there was this general rule, no hard coding, which is a very fuzzy rule, but it encourages generality. So you can use hard coding that if the reward is more than something, or you already have logs, now you will next get a wooden pickaxe. You cannot do that. You have to let the neural network or learned module handle that part. And the other part, which kind of is result of this rule and retraining, is that there was a limit on hardware you can use and the samples, which also equalizes the gaming field, by the way. So the server used to train the models were just a simple 6 CPU, 1 NVIDIA K80 GPU. Back then, this was actually still pretty decent. Not anymore, back then. And 4 days of training, so not that much. And this enforces sample efficiency. That was one of the main training points of the whole competition, so that we don't have to train on the game for like million years. And also equalizes the field, so somebody doesn't just train for millions of years on a cluster and win the game. But that might be a bit too restrictive. So this was the top solution. I'm just going to play it out a little while. Any question at this point? People may look at this. This is the, whoa. Oh. I can't mute this. Oh, wow. Huh? Let me, okay, well, whoops. That's interesting. I didn't hear that music when I was doing it. But anyway, this was the top solution. It was able to get some wooden pickaxe, get the tools. I guess we can just listen to the music. It's just some random music. Soothing. It's some very corrupt Minecraft music. Goes around, gets the logs. If you continue watching this further, I would make it faster. It starts to dig down, hits some stone, but then it just gets stuck there. So this was an agent just running. So that's very focused. So getting to the actual solutions. Wow, now it's very quiet. Getting to the actual solutions, I'm just going to open this up. There was 3 different quite unique solutions. There are now terms and things you might have not heard of, or you might have heard of. I'm not going to go super into this, but 2 things I want to point out in these 3 solutions. So 1, imitation learning was strong and very commonly used. So all of these solutions use imitation as at least part of the model or as the core of the whole model. And the second part was this desk-specific engineering. So remember the no hard coding rules, the no hard coding rule. People still kind of walk that very finicky line of doing making the actions a bit easier and adjusting the kind of what data to use and all these things. So it's kind of like they didn't really break the rules, but kind of yeah. But it was very effective. Like many of these things, if you remove these things which are highlighted in blue, then the agents don't work. So that was the outcome of the MineRL 2019. Any questions on that? I might just skip the other iterations of the competition more or less. Yeah, on the first one? Yeah, so there was multiple agents in the first solution, which were split, not quite hard-coded, but kind of, it was very finicky line. Any other questions? Yes? Yes, they get 8 million steps in the game, which corresponds to how many hours of gameplay. But yes, there was a budget for running the game running the AI on the game to train it. Right? Yes.
Is there a minimum data for the
Sorry?
Is there any minimum amount for the data set?
Like a minimal amount, how much data do you need to train it? That's a very good question. I guess it depends on the situation, what you're doing. Some of these actually clean the data set a little bit, only selecting the best parts. And it was only 10 or 20% of the data. So I don't know if this one I don't have a promising solution, but I would say that quality over quantity, and you can go by with a very little amount of data, if that answers the question at least vaguely. But moving on to the next iterations, I'm going to be quite fast on these because it's essentially the same competition again. And very quickly, these were run on NeurIPS. Very quickly, the reviewers were like, this again. And that was actually in the third iteration. They were, one of the comments was, people are getting tired of Minecraft. Well, I mean, we don't agree. The reviewers said that. Anyway, so problem in the previous competition, then no hardcoding rule, but it was a weak point. People still did that. So the solution was to obfuscate the inputs and outputs. So what that means is we had this equipped items and the inventory information, but those were encoded with a neural network into one, just a vector, just a number vector, which describes the inventory and describes the item in hand, but as a human, you cannot really tell what the numbers mean. And you had to work in this space. So all the information is in that weird vector of 64 numbers, no idea what it means. Good luck with that. The image still is an image, so you have to work based on that. And the same operation was done on the actions. So instead of knowing which actions corresponds to which patterns and so on, it's just a vector of numbers. If you change one number, who knows? It's not, might not be even a valid action. And that's just how they enforce that you don't fine tune the action space or something like that. And same rules in 2019. And getting to the outcomes, do you reckon, did the new solutions, were they better or worse than the previous year? Worse? Just yell. Better, better, worse? Same, worse? Split. That's quite split. I mean, they were worse. I mean, on one hand, yeah, exactly. NeurIPS reject. Go home. But yeah, sadly they got worse, which is kind of a not super surprising because the solutions were they were depending heavily on the tricks they had last year. So the results went down, which is kind of sad, but at least they were more promising solutions. Yes. We trusted the organizers. You also had access to the encoder, kind of, so you could still tweak your solution around the encoded things, and people could study it. So, yeah. Top solutions still varied. Again, bunch of numbers. I'm not going to go super into detail. I would recommend you read the competition like retrospectives. There's like a summary of the results. But again, the thing I want to highlight is imitation learning. Again, strong, used in every solution. Some of them even just relied solely on imitation learning. And again, that specific engineering is still strong, less prominent than in the previous year, but it's still there in different forms like clustering the actions, image augmentation, discarding the no-op actions, and so on. And then, guess what happened next year? It happened again. This was the time when I joined the organizing team and I saw the review of, we are getting tired of this, but they still accepted, so I don't know. So the problem was the activity went down, so number of submissions, number of views, all that went down. Maybe it also just wasn't so flashy anymore. So comment from people, it was difficult to get started and so on. So solution was to introduce an intro track where there was no rules at all. You just submit the model, we run it, and that's your score. Like no retraining or anything. Just let's see what people come up with, how high scores they get. And we still kept the research track as the obfuscated, where you have to kind of come up with a new proper solution. And same rules as 2020 apart from that. So how do you reckon the results changed in the original track, original settings now? Higher, down, same, up, down, up, down, up, up. Okay, this time it's going up. This time it's going up. So, okay, it's a bit small, but from 61 and 39, we went to 76. So yay, progress in the field, which is quite cool, yay. How do you reckon, though, happened with the easier track? 1 million. Up, down? Yeah, I mean, of course it goes up quite a bit. So it was like 79, now it's like 645. It has an exponential curve on the rewards, but this one actually got a diamond in one of the 100 episodes they ran. So yay, Optane diamond done. So there we go. With no any limitations, they finally got it. This one, I think it's trained a lot. Just some boring statistics. So the top intro solution, which is the easier track, 21% of the time they get a diamond. The research ones, they get to iron ingot, but they never make an iron pickaxe, which was kind of sad, but oh well, at least they are general solutions. And again, skimming through this in different solutions, but again, imitation learning was there, and task-specific engineering was this was the research track. So bit of hierarchy, multi-stage training, auxiliary tasks, so on. So my takeaway from all of these 3 years is that these tricks, like a task-specific engineering for that specific environment of game, it works really well. Like without that, you can keep throwing algorithms in, but even the biggest algorithm with the most compute doesn't really seem to cut it. So a little bit of tweaking is required. And then in the intro track, hard-crafted action space, reward shaping, trained with Impala for 2.5 billion steps, which is like 4 years of Minecraft time. They just took a cluster and ran it. I want to see the proposal to the manager, like, hey, can we have a cluster for Minecraft? So that was the end of MineRL competition as we know it. Do you have any questions before I move on to the other ones? I'm going very fast, but yes. Right. So why not allow to do task-specific optimization? Right. Because in the competition, the idea was to have general solutions that apply to the whole AI field or the near-apps field. So you could take the solutions and apply them to, say, Atari. But some of the solutions like action shaping based on human knowledge of Minecraft might only work in Minecraft. So you don't know how it works in like robotics or so. So the competition wanted to come up with results that work in other domains or have at least chance of working. There is a question. Yeah. It was 39 point something. Yeah. Yeah.
The second solution is a lower score than that.
Yeah, 13. Oh, sorry, 22. Yeah, so 39. Yeah, 39 is lower than 22. That's a very good point, and it's one fun thing to talk about in the retrospective of the competition, being like, oh wow, we had submissions which are worse than the previous year, which is not fun. But the methods were different. People weren't just submitting it was actually cool to see that they weren't just submitting the previous year's solution and to get a score and win the competition. They were actually coming up with new things. So while in the kind of getting the high score, it wasn't maybe the best idea, it was very cool to see new results. I will leave other questions for the later. Need to dash through. I want to talk about these were actually boring. The previous Minecraft results are by now actually kind of boring. So getting into other more recent and cooler results is starting with OpenAI's video pre-training. So OpenAI joined the game. Look at the competition. Actually, some of the organizers went there, and they just applied the OpenAI recipe of scrape the internet for all the Minecraft gameplay video, train a big model with behavioral cloning, fine-tune it with RL. This was before actually LLMs, which is kind of cool that they still have the same train on supervised data and then reinforcement learning. But yeah, fine-tune something and then prove it. So what the result was essentially on the very left, imitation learning model is on the very left. On the x-axis, you have the reinforcement learning training steps. How many episodes they trained for, and y-axis you have the quality again. And the imitation learning model was able to get like crafting tables and like some tools at the very beginning already, before any training, which was already pretty cool. But then after a little bit of training on then, I don't know, 50,000 CPUs and 800 GPUs or whatever they did, they finally get on the very right, 20% of the time they get the diamond. And this was in a slightly more difficult Minecraft version because they had to use like a more human-like environment than the previous one. So that was cool. They just come in and do what they do best. So I recommend you people read it because it's also very interesting results. Any questions about VP? Sorry? OpenAI video pre-training or OpenAI VPT. Any other questions?
The thing that was nifty and not just brute force was how they learned a model. They learned the inverse behavior analytics model from video to actions.
Yeah, that's a good point. So
we have some legal data and a ton of unlearned data.
right, that was the other part of the recipe, is that YouTube videos don't have the actions, right? So they hire people to play Minecraft for them. So, nice job. And then they use that data to train a model to predict actions for frames. And then they frame all the whatever internet data they have, and then they train on that. Oh, and this code is, well, not the training code, but the models are available and code to run it and maybe fine tune it a little bit. So if you want to play around with this in Minecraft, you can. MineRL BASALT. This one I want to spend a little bit more time, but which is very quickly running out. But this is a bit different type of task in Minecraft. So instead of, yep. So Berkeley organized this in 2021 alongside the diamond competition, which we talked about. And the general gist of this is that obtain a diamond is very easy to define. You give it +1 when it gets a diamond, simplest case, or you give some like reward shape and you tell it, okay, now you're getting close to the diamond, which is what we do. And then this is cool, but the problem is when you want a task like building a waterfall, you could specify it more accurately, but how do you define a waterfall and how do you quantify the correctness of a waterfall? And finding a cave, how do you quantify what is a cave? How do you quantify finding it? Like, how do you measure? How do you give a reward signal to this task? And these kind of problems are something we probably want to do also, not just finding diamonds, but something where the reward utility is very hard to define as a like scalar number. So what the BASALT 21 like a competition setup was on the evaluation side is that participants submit the code and the model to the evaluation server. They roll out the model and they record the agents playing the game. And then to evaluate these models, like which one is the best at building a waterfall or whatever, the organizers select at randomly. They have the whole data set of submissions. They select a random pairing of different submissions and show them side by side on like an online form. And then they ask a bunch of human evaluators on like AmTurk or something to answer which of these two was better at solving the task. And from there, you come up with a score. Actually, they use TrueScale to determine which of the submissions was the best, according to humans. Any questions on this? I would, personally, this is my favorite stuff so far. Any questions on this? Yes?
Did the people building the agents know that they had to do this task?
Yes.
Okay.
So they knew the description of build a waterfall, you have these items, you have this time, this number of time, do these steps. But that was quite short, so you don't get like exact details. So it really was up to the humans, or like the competitors and the evaluators of defining what is a waterfall. But the idea of the competition was that everyone has an idea of a waterfall. Other questions? Okay. And again, in a true MineRL fashion, run it again without many modifications. So it turned out to be very difficult trying to build a waterfall. This is one of the, not top 1, I think top 2, but it's not very good at building a waterfall. It just wiggles around and doesn't really do anything. I think this one just jumps off the cliff eventually. In a future, I'll attempt to escape. But so in 2020, in the next iteration, we provided a bit more better ingredients. So we provided the OpenAI VPT model as a baseline because the model was actually pretty good at navigating around and doing basic Minecraft stuff. And we collected, thanks to OpenAI, 700 gigs of like human demonstrations because they still had the contractors around and we were like, can we have them? And we got the data. That was pretty cool. Mind you, I wasn't here yet at that point. But these were the data we gave them to work on this. And the results were quite much better than in 2021. So which one of these do you think is better at building a waterfall? Left, right.
Letter of the law, not the spirit of the law. Yeah, exactly.
So what do you think? Left or right? Left is better. Anyone? Right? Right? Both? L? Right? 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 Okay, so no, exactly. That's what the evaluators also agreed on, that the first place was actually a bunch of hardcode steps. That was actually allowed in this competition. We want to give them like free hands on doing anything to solve these tasks. We hoped that it would be something neural networks or fancier, but we also didn't want to constrain them. So first place was actually hardcode steps quite a bit. So looking down, place on code blocks, place of water. I mean, it's a waterfall essentially. So evaluators were like, yeah, seems about right. Second place sometimes did something actually, but that was a VPT fine-tuned to like replicate human demonstrations. Sorry? Yeah. Oh wow, I didn't know it actually places one. I actually haven't watched this video so long that I did. But yeah, how many submissions did we get? No, we did have like 7, 8, something along those lines. So it was decent. Any questions about BASALT? I want to skim through the very recent results quickly. No? Okay, so very quickly to the freshly baked results outside MineRL, which just came this year or a couple of months ago or so on. So MineDojo, last year, NVIDIA took the MineRL package, added in some YouTube data or links to the YouTube data, Minecraft wiki data, Reddit data, a model that connects images and language so you can like see if they correlate, the MineClip model, and thousands of tasks. So they essentially took MineRL and refined it into much more like a wider set of tasks, a bit more data, more utilities to actually solve them. Dreamer v3 from Hafner, I believe mine or Google Brain, but whatever. So I learned to dream in Minecraft, so a world model that was mentioned a couple of times before. So it learns to dream Minecraft and learn in that dream to do more sample efficient training. So it plays around, learns to dream Minecraft, and then learns in that dream, essentially. And this one reads diamonds without demonstrations or pre-training. So no imitation learning, and it reads diamonds. I would want to put a very big, huge asterisk there, though, regarding what they did with the environment, which is I'm pretty miffed about, but I will leave it to you to read about it. They didn't exactly use the same environment than the other companies. So it's not, I would caution you to, when you're reading these results, check the environment settings, because there might be some surprises in there. But still, nevertheless, very cool results. There was a question?
Did the learning the dream part, did they learn off the imitation data?
No, there is no data here. There is no imitation or anything. It's all just the agent in Minecraft goes around, learns to dream the Minecraft as it goes, and uses that. Then Steve One from University of Toronto, they took the OpenAI VPT model, which was capable of going around, but it wasn't controllable in any sense. But then they combined it with the MineDojo's MineClip model to create like an agent that's essentially controllable. So you can say like the input like co-explore, and it just goes around, collects the seeds, it starts to collecting seeds. So this was a very cool demonstration of, you didn't have to train anything. They just took OpenAI VPT and the MineClip and a little bit of data and a little bit of training, not much, and they get this. So a controllable agent. Voyager, I assume some of, at least it came up before, and I promised to mention this. Again, from the NVIDIA, from the same people as the MineDojo, they took GPT-4 and GPT 3.5, the Minecraft bot API, MineFlyer, and added in some iteration that it kind of asks the GPT-4, how do I get this? And then it writes the code in MineFlyer, executes that code, and does things along that way. And it stores the skills, like skills that seem to work in a repertoire to kind of summon them again and change these skills together. So essentially planning with the large language model, just ask how to do this, and then it writes the code. Oh, wow, it's not playing the video. But yeah. Sorry? Yeah, now it's playing, yep. Well, yeah, this is the Voyager bot going around. I want to maybe say that they did this in the code base, which is for you people, it might be very relevant if you have like a code API to your games. Just don't make sure not to compare it to the pixel-based solutions, which were previously. But this is very cool stuff. And they can complete many different things, collect a bunch of different items. In a very similar vein, Ghost in the Minecraft from Tsinghua University. Again, GPT 3.5, decomposing the goal into subtasks and planning, and some other tricks there. And they obtain all the overworld items, so they can like explore around, craft different items, and they explore the game enough to find all the items you can reach without going to underground or like the hell and stuff. So with those, there's still a couple of more, but I can't remember the names. But wrapping up, because only 6 minutes left. This is cool and all, but what now? If I were to kind of like tell someone based on all these things, all that has happened, I would say that there's a lot of amazing results with the VPT and everything, especially with the LLMs. I know everyone doesn't like them, but they are here and they do things. But it's very hard to say what is the coolest model in town. So we had like 3 models, or actually 2 in the slides, but I assume there's more that do things in Minecraft. But which of them is actually better? What it even means to be better? And like how to measure it and what should we do with that? And then the other thing I would want to say is that capitalize on the publicly shared models instead of trying to train everything from scratch, because that's how you get some results. And the people who are training the models might not have time to actually start applying to every little thing. So the crux here is assume that the agents are getting more capable, or these kind of AIs are getting more capable all around in the next year or so. What challenges should we focus next? Or what is even the challenge? Like, is the evaluation the challenge? Which one is the best one? Which one is the worst one? What is even the challenge anymore? Or what should we do with these models? And I feel like this I just added a couple of hours ago. This game AI community, this summer school, this is pretty cool fit for this because there's like ideas and things you could do with this, which are very suitable for this community. So in this summer school, maybe you want to explore some of the ideas like this. And just final takeaways. Previous slide was kind of the takeaways. Minecraft is still a cool AI research platform and cool game. It keeps challenging the researchers. It's still not complete, even though there was a lot of progress. Train pre-trained models with offline datasets for quick gains, and use pre-trained models, which you can find, because training these actually takes quite a bit of resource and time. Lots of amazing results coming out with LLMs. And this would especially work well with the scripted AIs or when you have a pod API. And finally, as a bonus tip, record and store videos when you're working on the AIs you create, because then it's going to be much easier to use them in the presentation. Because, boy, I spent too many hours trying to find videos of the agents from the competitions, but they were lost in time. So with that, actually finishing in time, thank you very much.